Okay, so I am finally back. So I have not been posting updates to Glitter or any videos for a few months now. So I thought it would be good to go through what I'm actually been doing, which is not a sprite sheet tool, but that will be a thing in the next version. But I have been working on, so we'll go through the basic the basic problem. But it's not just this. This is slightly. Sorry, having a drink. If I go to the stage and the scripts, and I go flag, I could say int x equals 4, and then I could say print x. But most languages you can do int y equals 5, and you can go print y, and so that's what a normal language would allow you to do. Scratch doesn't allow you to have these local variables. So this is a local variable. So I want Glitter to do local variables, but if you actually compile this, it works fine. It says x, y, and x. So you're like, well, it does have local variables. What are you talking about? Not exactly. It doesn't exactly have local variables. This is create an apple. And we'll use an example here. I could have just done this without an apple. We'll go flag. Actually, we won't. We'll forget the apple. We're going to go repeat 10. So this is actually an interesting example, I think, where maybe it shouldn't do what it does. We'll find out. Y equals y plus 1. Okay? And then we're going to print it out again. Y. If this actually works, I'll be kind of annoyed. If we do that, oh my gosh, it does work. I hate myself for being smarter than I should be. All right. We'll take this and we're going to put this in the, we're going to put this in here. And into my apple. And then I'm just going to say turn left, Y. All right. Now, when I compile it, it's going to say requires, it gives you a rather odd error, but it says requires root level context. So you do not have full local variables in Glitter, even though sometimes it seems like you do, but you don't. And so in this video, I'm going to talk about my work towards getting it to do this, and then also what on earth is going on here? Why could I do it a minute ago, but now I can't do it? What is actually happening under the hood? So this will be a big reveal. This is going to be a long video. All right. So anyway, the first thing is we're going to take a moment to move away from Scratch, from Glitter. The thing that I've been trying to do, so if you go to the preferences in here, there is a use experimental IR engine, and this is what I call the internal runner engine. This is the thing that runs your project inside of Glitter, and the experimental one is an upgraded version that will allow for local variables, and is also somewhat faster. It's like at least 100% faster, and will probably be considerably faster later on. It doesn't handle like some things like thread control, which like stopping threads and stopping other threads and that kind of thing. Sometimes it gets confused, so it's experimental at the moment. It doesn't quite work. I was hoping to have this finished for the next version, but it will get done. But the thing is, in order to get all of this settled out, I have to get all the outputs as close as I can to being able to do local variables. The C64 stuff is in fact kind of set up to do local variables, so that's not a problem. But the HTML output is not really set up to do local variables. So I started working, and we're going to have a look at some code here. I started working. So the way we'll quickly go through. Hold on, I'm just gonna. Oh, how am I gonna do this? I'm just gonna drag it out. Okay, hold on. Where is the original one? It's here. All right. So it's not a very fancy HTML output thing, but there are two. When you create an HTML project, it creates two separate JavaScript files. One of them is called support.js. It's only called support.js.txt here because I'm lazy and I'm using Eclipse, and I don't have a JavaScript editor installed, and so I just call it .text internally so it doesn't complain every time I click on it. Yeah, everything's going to be like in boring black and white. So basically this is just a straight JavaScript file, kind of, and it's all the support code that goes behind, that's fixed for every single project you have, and it's all kind of weird and messy and has changed over time. So I started off and I went through and I changed the thread controller, the thread manager stuff, to be a different sort of style, which makes much more sense. If you look at how it works at the moment, you'll be like, why on earth did he do this? Well, I'm sure it made sense at some point in the past. And I did that and I upgraded it, which I'm not going to show you the code for it. And that was fine. And then I ran some tests and it looks like it was good. But there are two parts to the HTML output. This is the static file that's always the same no matter what your project is. It's all the support routine. So there's lots of weird thread stuff, lots of weird hacks to match up with Scratch, some support things, some built-in functions, and a whole bunch of other things. So this is how it's handling all the forever boxes and things like this. It's a bit over the top. Like if you look at how Penguin mod or whatever it's called does it does it a very different way to what I'm doing it, but I might explain why later on I'm doing it differently. But anyway, I have to generate code. So the thing we're going to talk about today mainly is generating code, and it's been like a personal thing of mine because I make lots of things that generate code in other languages, or it's my code can, and I've done a variety of ways of trying to do this over the years, and we're going to pretty much go through them all today. So the first thing, how did I used to do it in the olden days? And the answer is, I'm not actually sure where I put it. Hold on. I'm just trying to find the project file. Here we go. So I used for the HTML output a little language thing that I made quite a few years ago, which is for creating like structured text or creating like it's a tool that creates code that you then use to create other bits of text. And so that's a general thing that isn't related to programming languages, but it is used here to create code, to create like the output code. And we'll have to go down to something that looks a bit more complicated to explain how this kind of works. But basically you define blocks. They have like a bunch of parameters, like there's a scene setup, and then they have a bunch of sub parameters, so that you can have 0 or more scene instances, and they're of type object of type scene sprite setup, and some events. And then there's these output blocks, and there's a whole variety of weird syntax to do a whole variety of weird things. And you're outputting code, and they're between these little double quotes. There's two single quotes together. There's a whole variety of different, like that just means it's a new line character. That means it's a semicolon. This is a reference to a variable. it gets, I'm not going to go into how this all works. It has its uses, and it worked kind of well for this, but you get all of this stuff. This is here is creating the constructor for a particular class. And you can see I have all this stuff here, which is a reference to a constant variable at the top of the file, all that constant stuff. And I kind of over the years worked it in, hacked it in so that I can do more stuff for writing. So that's what all this weird stuff here is, to do what I want. But it doesn't understand JavaScript or anything like that. And so it can be very, very tedious. This doesn't work because variable blah blah blah. It doesn't work very well because it doesn't understand JavaScript, so it doesn't do any checking of the JavaScript, and so it outputs code. Sorry. It outputs code that could be completely wrong, and you have to go through a horrible process. So this file is given to another tool. That tool outputs a whole pile of Java code, and then the actual Glitter tool uses the outputted Java code to generate the final code. So if I change anything here, I have to go through and recompile everything. It doesn't take that long, but it can be a pain, right? But this is not the way that I have done code generation in the past. So my first effort to do code generation is one that does understand at least something about the underlying language you're generating, and in particular Java. So I will give you an example of Java. So that project was called Skeleton, and this is the part of the skeleton file that it's used to create the parser generator code that I use to parse all the languages that I'm coming up with. Yeah, so I wrote all that myself. So it's a pig. I don't know, the parsing expression grammar uses, I can't remember the names of the terms anymore. Pack rack parsing, that's right. It's right there in the name. But it handles left recursion and everything nice and easily, and it has lots of extra features. But I use the skeleton thing to output Java. So if we actually this is all just defining the data structures that you're interacting with. So again, this is outputting code that is used to output code. So it gets very confusing very quickly as to what I'm actually doing here. But if you come down here, we still haven't actually got to the code. All right, so here we're defining an interface. This here is the internal name of the class, and this is the actual generated name of the class. So this is going to take class name as the variable that's hidden somewhere. So skeleton variables have $sign at the start. This is just an ID. But you are still working with, it's hard to see deep down, but there's a lot of, this is actual Java, and it will complain if you don't. It checks so that you know that you're using the right variables. It will tell you, oh, this variable is unknown, this function is unknown. It will construct the classes and everything. And you see output the packages, and has a whole bunch of other weird code. But as you can see, it's very hard to read, and it gets very confusing very quickly as to what is really happening. And part of that is these projects are very complicated. The parser generator is outputting quite complicated code. And the skeleton version of this, because it actually uses itself, well, it uses another version of itself to generate its own code for outputting stuff. It's also incredibly complicated and it's quite tedious. And there's just lots of little things. This thing is not a programming language. It's not an imperative programming language. It's not a language that's giving commands. It's more a declarative language. It's not. I mean, I'm abusing the terms, but it's a language where I can't just say if this, else that, blah blah blah, do loops or whatever. I'm just declaring how things are, and it's generating things based on that. That's quite useful for some things, and it has a lot of weird, how do you understand the scope of things? It's very complicated. It's too complicated. And so I've always been thinking about what's another way of doing this. And so that's the skeleton way, and that's still used. That's used for generating the complicated Java projects that I've worked on. But it's not that useful. So we'll keep that there. We're going to talk now about something that is used within skeleton, within Glitter, which is used for the Commodore 64 side of it, and is also going to be used for the microcontroller stuff. And so what is that? Okay, this is the code. This is kind of the font's too big now. I think I made the font too big. So these are jumbled files. It's pronounced jumbled here, but I changed my mind and just got it jumbled. So this is basically a programming language that's not a declarative one. It's an imperative one. You can do ifs and stuff. But its purpose is to generate code for another output. And in this case, it's generating assembler code. So originally I had thought, well, I need to generate assembler code. So what I could do is I could generate a tool that outputs the text files, and then I could text version of the machine code assembler language files, and then output that to somebody else's assembler. But I don't like doing it that way. It feels like over the top. So what we have here is everything's kind of combined into one. So this is just defining some constants. I don't think it has a constant keyword. I don't think I got around to doing that. So these are actually changeable. I just put them in uppercase letters to tell me not to change them. The most important thing is we have this thing called design. And how does this work? Oh, this is just specifics. All right, so we have an external design. All right, C64 specs. That can't be right. Those the only things? Details, use basic. Where does the actual cool stuff come into it? Well, we'll come to it. I can't remember where the actual design is. We will find the design. What's it going to be called? MLG. Oh, here we go. All right, that's the specifics for the Commodore 64. But there's a design file. So there are two components to this, and this will come again and later. The first is there is a design, and so it's called MLG. I think it's just machine language glitter. And basically it's a bunch of, like, a declaration of basically structures. So you have a project detail structure, and it has all of these particular components. It has a name, it has a bunch of statements, a bunch of byte variables, ushorts, blah, blah, blah. And then you come down here and you can see somewhere, where are the statements? Well, the statement will look like this. The statement is a group, and so a statement can be one of any of these following kind of things. So the main idea is there is a whole list of these structures, or record, I call them records internally, that just have a whole bunch of attributes or parameters to them, which can include single or arrays of other records. It has a root, which is just said that this one's the root. I think I might change I think I have changed the way this actually functions. But the important thing is you have that, and then you have this idea of groups. So a group is something that can be one of a set of different types of records. So an expression is one of these things. So whenever you see me talking about, or whenever the code is talking, like here we have a Boolean expression. This just says an AND has a Boolean expression, and it has a Boolean expression, and a Boolean expression can be any one of these things. and you can kind of see what's currently there. And so this design, this is the only thing that results in generated Java code. So the Jumble tool will take a design and then it will generate nice Java code. Sorry, stupid Coke can. Nice Java code that you can then interact with from your Java program, which in my case is Glitter. So Glitter will interact with the data structure and use this. So it just, you have to build up some sort of data that is then fed into the actual main code. So here we go. Here's the inline design. And because this is a bit hacky, I've only got inline. You can just inline things. This is an older code. I am moving towards, as we will see, a more finished version of this approach. And this has also some other weird work for how bytes and stuff are stored in memory, because this is all the assembler stuff. So we haven't actually seen any assembler. We'll come back to the adjusts. The adjusts are important as well. But the important thing is we have functions. So this is like a normal programming language. We have functions. And in a function, you can specify assembler language opcodes, and that just means output these opcodes. So this is an output statement. This is output to the final thing. Whenever this bit of code is run, it's just going to output those things at the current memory location. So it's working kind of like a normal assembler. So we'll look at the, oh my gosh, too complicated C64 expression generator. So this has a whole bunch of functions. You can call other functions. You can pass in parameters. This is a reference to the design. So you're passing in data. Basically, the design is a definition of a structured data format that you have to pass into the assembler part of it. That is given in a sort of generic format, which is kind of tedious to write. So there is code to generate Java code so that that's not so tedious to work with, and it's typed and everything, and that all works. But the rest of it is all handled at runtime. So when you start up Glitter, it reads in all of this code, it compiles it, and has it ready to go if you want to compile Java code. And so when you come down to here, so exp is a byte expression, and if I go back to the design, oh, I've gone and changed something. I don't want to change anything. All right. If I go back to the, I want the actual design. This one. Byte expression. So, oh, it's going to be hard to explain this. We won't explain it too much. But anyway, I'm getting a reference to the byte expression from, which is going to look like Boolean here. So it's a group thing. Pardon me again. I probably shouldn't have eaten some cashew nuts before I started this. But anyway, on here, this is the syntax for dealing with groups. So you say on exp, which is this thing here, this variable, which is a byte expression. And then for all the different types of things that group can be, you have separate code. And you have to include them all. If you don't include them all, it says you missed out this one, so you have to add that one in. So if I was doing a subtract, I am going to build my first expression to write, and then I'm going to store that in my storage thing, which I don't know where that came from, but where does that? Oh, that will be somewhere. Oh, right, it's a label right down here. That's impressively hacky. So basically, I'm reading a byte. This will build code that will read an expression into the accumulator, and it will take. This is the right-hand side of the subtract. So subtract has a right and a left. That's where that variable came from. And then I'm going to store that. I'm hacking it. I'm storing it. I'm doing self-modifying code. I'm storing it in this operand of this command down here, and then I'm building the left-hand one. I'm clearing, setting the carry bit. Doesn't matter if you don't understand this. Is just 6502 assembler language. And then I'm subtracting from the left, I'm subtracting the right. So I put the left into this thing called an accumulator, but first I put the right into the accumulator, but then I stored that over here. So this is how this is how I've hacked it together. But anyway, the point is that's how that will work, but I need to find some examples of actual program code. It's hard to see, but you can go if test equals 32, for example, blah blah blah, and you can go print hello and things like this, and they all run. This is a programming language. The only thing is you have these address variables, and address variables are variables that may not be set yet. They can be set in the future. It's just because when you're doing programming code, sometimes you're jumping to a location that hasn't been assembled yet, hasn't been encountered yet. And you can kind of, well, you saw that back here, right? Where I did that sort of thing with the subtract. Where did you go? No, I don't know. But it's there somewhere. I can't get any good examples. Hold on, are there any other really interesting examples of coding? Oh, okay, here we go. Here's an interesting example. Here, for some reason, build the same code for 4 digits, right? So I've created an offset of 4, and I've done an actual while loop in here, and it's gone through, and it's doing this bit of output that many times for each digit. So the point of all of this is that the assembler is not just taking your code and assembling it. It's a language that takes a design and uses that design to output code in a particular way. So I've offloaded it. You can read my comments. I've offloaded. These are commands that get translated by the. I've offloaded it, the work from Glitter to the actual assembler file to interpret the design and output the right kind of efficient code instead of doing it. It makes a lot more sense. Like you can add an extra command. There's no LBBC. That just sort of manages if you're doing long jumps and things like this. And these commands here will actually print out debug information, but they get compiled to things that my internal emulator understand. So they're not proper Commodore 64 output, but they are part of the output for the emulator, and then the emulator will print out debug information or dump memory or print out the registers and all that kind of stuff. So that helps an awful lot for debugging stuff. I think it actually does have structures. It has a whole bunch of things. Who knows? It's been a while since I worked on this. I am coming back to the Commodore 64 stuff later on this year. But the good thing about this is that it is recompiled every time you restart it. It's not generating, except for the design, it's not generating fixed Java code. So at some point you will be able to edit this code from within Glitter, and so you can add new features or modify the code and change it how you want. So people want to contribute to the project. Obviously there's only going to be so far that I'm going to go with the Commodore 64 stuff. Like if you want to have 8-way scrolling, super cool games and everything like this, I'm not going to spend my life writing all the details for cutting edge Java Commodore 64 code. So someone else can do that. Can get rid of that though. All right. So we've got there. Now you're like, well, you started off talking about local variables, and then you've really gone and got sidetracked. And the answer is, am I still recording? I am still recording. How long have I been recording for? 29 minutes. All right. So how does this relate to what I started with? How does this relate to HTML output for local variables? Well, I went in, I did my code, I upgraded this thing, and then I got like depressed at trying to work with this mess of an output, right? This is the old way of generating code, which is also a to a degree a little bit of programming ability in there, but not much. So I decided, what the hey, let's just do what I've been trying to do for ages, and create another attempt at a code generating tool, which is a little bit like, which draws inspiration from the one that's used for the Commodore 64 stuff, in which they're going to be combined to sort of a set of tools that go together. And so the new system that we now have, it's always going to be another one. Well, there are two parts for it. So first off, here's my test thing. So the new thing is called Sane at the moment. Who knows why? Again, we have the exact same design structure, except the root's moved over to there. That's the root thing. The root thing just comes down to how we interact with things. But again, there's a design, same kind of structure. You've got a bunch of like records that have like a name and that, and then there's shape, which is a group in this case, which can be one of these two kinds of things, and you can add things in. But we're not outputting. So this is the random test code. I haven't written. I write the same things over and over again when I do my test code. So in this case, now we're outputting we're not writing in JavaScript, we're writing in typed JavaScript. So the first thing you could have said, like the first thing I wanted to do is I hate writing in JavaScript. And so I wanted a typed version of this that checks that I'm using the right variables, and that does all the checking before I actually, so I can compile it instead of having to test it in the browser and all this kind of stuff. And I know people will say, well, you could just use TypeScript, and that's true. Like, I didn't think about using TypeScript, but the problem with using TypeScript is I have to now use a third-party tool that I have to install with it, or only use it for the I could use the support thing. I could rewrite this in TypeScript and then just compile it to JavaScript and then work with that within Glitter. But that's a pain. It doesn't give me what I want. And I have to use a third-party tool. And it's kind of not that important. Like, of the last couple of months, the trivial part has basically been creating a typed version of JavaScript, to be honest. And so this is going to get a bit weird. So this is my little attempt, well, my probably fourth or fifth attempt of merging two different languages together, where you have this idea of macro components, is what I usually call them, and there are output components or target components or app components, which is what you're generating, or your generated components. And the problem that I'm doing and making things hard is that they're the same kind of language merged together. So this is going to make sense in a second. With the Commodore 64 stuff, you can pull this off because the programming part kind of looks a bit like Java, all right, or a C language. So, you call functions in exactly the same way. You do if statements and while statements and loops and everything in roughly the same way. I mean, the language is a bit different. I say the word function up here. You can't return values or anything, so there's no return type. But It's that, but you're outputting code which is definitely not Java, right? You're outputting 6502 assembly language or other assembly. You're outputting opcode. So there's a sort of nice separation between the target language, which is machine code, and the macro language, which looks a bit like Java. But in the case of this stuff, the target language still looks a little bit like Java, but the output language, the macro language looks a bit like Java, and so does the target language. They both use curly brackets, and they both do all the same kind of thing. I didn't talk about the adjust blocks, which we can come back to later on. So how does this work? Well, we'll start off first just talking about forgetting the code generation stuff is. We'll just look at what does this look like? That's not what I want. That's a bit boring. Okay, so this is the graphics. So this is like a graphics class. So there's a canvas interface to the underlying graphics context 2D. I'm not going to go, like, if you don't know JavaScript, doesn't really matter. This is just to manage the translation between scratch space or glitter space coordinates and the standard graphics context 2D. So most most graphics things, or like simple graphics things, they start in the top left-hand corner as 0, 0, and then X goes positive as you go along, and then Y goes positive as you go down, which does not match what Scratch or Glitter does. Glitter, Y goes up, starts in the middle, and Y is increasing going up, and Y is decreasing going down. So that's just strange, but that doesn't matter. All that matters is, so you're just writing it basically like Java. So I've written this is that, this is a array. And then someone's going to say, well, you should do it like, all the other new languages, and say function and put colons at the end and put the type at the other side. And it's like, I hate that. Like, I'm sorry, I don't care. I'm just going to write it like the way that I'm used to writing it, because this is my tool and it's for me, so I don't care. So you can do it your TypeScript way if you want. But I'm doing it so it looks basically like Java, except you say constructor instead of saying gcanvas. So it basically is Java. You can say this thing. You don't have to say this, so that's like one of the nice things. Like, I mean, you can if you want, but in JavaScript, if you put it in a class, if you don't say this, it doesn't like it. And if you get, there's all these little quirky things you get from JavaScript, so I have to actually point those out or do it correctly and translate it to something that makes sense. But basically, it's all just typed Java-ish code with a few extra things to accommodate some JavaScript things. You have interfaces. Interfaces don't ever occur in the actual outputted code because JavaScript doesn't need them. It just tells me that these things conform to a certain nature, and you have to say. So normally, if this implemented something, you have to say implements. I know everybody likes duck typing. TypeScript does it, but it's like that just feels like I'd rather be forced to write everything out explicitly because it makes it more readable. I'm not a huge comment person because I like code that is explicit and verbose and that makes it obvious what it's doing. Is my preferred way of doing things. So you can now create new inline classes, just kind of like you would do in Java. So this is saying this is a new rotate style. So this is an object that implements this interface. If you get the wrong, blah blah blah, it will give you an error, so that doesn't work. If you get the parameters wrong, that will say that doesn't work. If you return 5, it will tell you that doesn't work. It does limited checking for returning everything, but I didn't quite finish that. But at some point, it will say, "Oh, you forgot to return a value," and all of that. And so, it's just like I can write. And the major point of this is not just that I want to output JavaScript. I'm going to use exactly the same framework to output definitely C code and just hack together classes with C. and interfaces. And probably what would be quite a good target language is also probably Dart, because I think I can use Flutter to create. So I'm looking for a more general output language to create across different. So I'm going to create like C code that will compile with SDL, or I'm going to create Dart code. And this looks a lot. It looks similar to Dart code. So that's not going to be too stressful. And that's going to just use Flutter, which again can be used on multiple targets. Instead of having to go through and write everything for every different type of target under the sun. So that's the basics of that. And that all works fine. It always works sweet. Does everything nice. You can't do weird things. There's always these weird parts though, because obviously in JavaScript isn't typed, and you can set variables to whatever you want, and it plays into things, and you have to do lots of weird things. But that's that. But now we have to look at how we write code. We'll go back to the test thing. I won't go too much into the language, to the actual outputting code that I'm working on. But again, what we have here is slightly nicely better written. We can import our design, which is my test design. So there's a design. I think I can show you the design. So this is the design for the Glitter current HTML output code. This is basically just a copy of the of this stuff here, but converted into the new design language. And then, so I don't need to say CBE anymore. That was just to make it easier to go find and replace, copy, to search for things. But that means it should be pretty trivial once this is all ready to go to slot it into the current software, current version of Glitter to get it to use the new framework. But I want to go back to this one here. So I have a design. These extern things, these are just tools for referencing external JavaScript functions that aren't built in. So if I wanted to call get element by ID on document and get an element, I need to declare that as a class, and then I say that the document, there's an external document variable and it's of type document, and then I can go document dot, well, it's on the next line right there, document dot blah 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 blah. So that's just thing. So this is just how do I interact with the user of this. So remember, this is not a tool for like anybody but programmers. This is a tool for the programmers of other things. So this is a tool for the programmer, me, of Glitter. So this is to do with how I interact with this. So this just says the design. I think the name happy comes from that's a happy design. So this is input. It's called, the variable name's happy, and in the very general, everything's text, like referenced. I'm not going to go into it, but there's like an underlying data structure you have to generate from your user code to talk to the compiler. And this is just telling you how I've set it up. All right, so now I have a happy variable, which is something which is of the type described by this design. So the first, it will be pointing to a moo, and it will have a zoom with an X and a cat and some things, and then from there I can get to the other objects. This will become more obvious. So then I can say @let. This makes a macro variable called number. So if I'm talking about macro variables, I normally have to put a $sign. I have to put a $sign. So this is saying, give me the value of the macro variable number, and then I can reassign it, and then I can print it out again. This is not a command. This is not a macro command. This just gets output to. This will get turned into console.log number, blah, blah, blah. So it will just output console.log. So this is outputting code. So it's mixing two things up. So it can get confusing what is actually happening here. If I was going to print while I'm doing the generating, I would have to have an @print command, which I don't currently have. So that would be the macro. So this one, I'm trying to differentiate things as much as possible by using $signs and @. So commands have an @ in front of them. So when there are functions, there aren't actually macro functions yet. I would go @moo, 3 or something, and that would pass in 3 to the function moo. Whereas if I typed moo by itself, I'm calling the target moo, if there was one defined. So we have this adjustment stuff. I'm not going to go into this too much. This is basically how I can add. It is more obvious in here. Do I not have the adjustment block stuff? Adjusting things is just so I've defined a design, but different things that work with the design might want to store extra information with these records. So adjustments is just how I can add. So in this case, I'm adding an extra variable called extra to moo. So there's my moo. So now moo will have an extra variable called an extra component called extra that I can add and change and use for storage while I do stuff. This sort of language is not actually used because I've changed my mind about things. Down here, I'm declaring x equals 4. This just gets translated to let x equals 4. So that's with the JavaScript. And this is a macro command, so I'm just saying if this is true, then I do this thing here. If it's not, I'm not outputting that command. But the other way of declaring macro variables is just the same way. So I could go int x equals 4, which we just did, is a target language command, so that will output let x equal 4. But if I do that, it's not outputting anything. It's just creating a macro variable called x and giving it the value 4. So that's what's happening here. This is a macro variable. It's nothing to do with the output code. And so then I can reference there, and then I can do the same kind of framework, except I have to say on, that I did in the assembler stuff. I say on this value here, which is what is HC is a happy.cat. So if we look at the design, happy cat, and cat has an S, which is the shape, and the shape S is of type shape. So here it's just saying on happy cat .s, which is in this variable HC. Then I have to either have a circle or a rectangle, and depending on what that is, I will output different types of code. So you've got interactions between the macro variables and the normal variables. We have an interface down here, and some more test commands. Again, if we can do while and for each and for as well. So coming down here, this is where it gets kind of interesting. I had to create a toNum thing because I don't think I changed the way that double equals works. Double equals now works like triple equals, I think. So it's a reference only operator, whereas triple equals is the equality compare it. Like, I think I might actually change it to also you can use is, like in Python, because it is confusing. This is going to bite me in the rear end at some point, but I'm like, I hate JavaScript. So anyway, that's just a test of all these things. Now the important thing, oh yeah, and you can define functions. So this is a function that takes an integer value and returns an int. And then this is defining equals function int return x plus 1. And then I can call that function. So that's how I handled the syntax of inline functions. But the for each thing uses the colon. It will probably also use in, but I'm a bit worried about that because in JavaScript, in and like there's two different ways of doing this, and one's just bonkers and useless. And so this is the JavaScript way of doing it. I mean, the Java way of doing it. So, tough. Just stick with that. So then I don't forget what everything is doing. Now, where things get kind of interesting is assigning classes and assigning things to variables, to macro variables. In this case, I can assign things to records. So I can assign a class as belonging to a particular record, and that record is whatever is in the HC variable at the moment. And I can do this. So for each T2 in things, so I think things is just this array of things here. So thing is just the thing that has a name. So then I'm creating a variable. Yeah, so this is saying I'm going to create this variable, which is called moo, and I'm going to give it, this is going to seem very complicated at first. The code here is what is the actual outputted name. That's the actual outputted name. So it might be moo.cat or moo.cat or something like that. And this is the internal, what I'm going to refer to it as. So if I'm going down here, I'm going to say moo.doThing. But remember, I'm doing this for each value in things. So I'm creating a bunch of different, we have to go down to the, where do I actually create it? Dun, dun, dun. Oh, here we go. So for each thing in things, I am going to create a class called single thing, but the single thing is going to have a different name for each thing. And then I'm going to attach it to this record here. So I'm attaching this class object to here, and then it's doing all of this kind of stuff and it's adding that up. I'm using a counter here, so you can do operations and stuff and then use that as part of the construction of the names. And then up here, I'm creating a bunch of variables of that type attached to that record. So this is the same set of things that we had before, but for each of them, so this thing here is going to create classes. So it gets kind of weird because this has been declared afterwards, but it's running the code in order down the page, but it knows that this might not be set yet, so it's not going to have a problem with that. It's going to set it once it's created down here. It's always a problem in these languages when you have to reference things in the future in your output. So it gets confusing compared to normal languages, because normal languages you do refer to things defined later in a text file, but that's in the compilation stage. And the important thing to remember here is this is actually in the generating stage. So you've compiled your code and then you run it to generate the final code. So there's this intermediate step. And so you can then do that. And you can in fact do this with multiple variables. So you could define, if there was something else, XC. So you can have a pattern, which is a way of referring to this class. You have to have a pattern. This class is referred to and only obtainable once you have a pattern according to these two record variables. So these two have a type. So this might be a record of one type, and this is a record of another type. And then when you refer to it later on, you have to pass in variables, and then you can obtain access to this thing. And you can do that with the only thing is, this it's very hard to explain this. This is referring back to the skeleton project. So the problem where you have two different languages interacting, where you have this macro language and you have this target language, is that sometimes it doesn't make sense. Like I can sit there and I can say count equals count plus 1 because I'm not within a class. It doesn't make any sense to. So you have this problem where classes don't have statements in them. They have to have like functions or variables or constructors, and within those things you can have statements. So how do you put in target macro level statements? Do I have to put them within the class? Am I allowed to go int y equals 5 print, and then do some, while y is less than 10, right? That would be an at while though. Can I do? Well, you can't at the moment, so I decided you can't. But you can do referring back to skeleton, which had these link statements. So you can actually just go link. This is not quite finished because you still have to do this. You have to attach this function to something, but later on, when you do link statements, it will automatically attach it to the variable, the record that your current, like I don't know if I can explain this that easily. You'll have to just I have to write it up someday. It makes a lot more sense but it's hard to explain if you're not used to the language. It's a new language, right? So it's always going to be hard. But down here you go for each. So within in the world, though there will be links. So the difference between a for each, I think you can go for each because I keep writing out the word for each, so I added that in as well. The difference between a for and a for each, apart from the fact that one doesn't have brackets and one does. The reason this one doesn't have brackets is because in skeleton it doesn't have brackets, and I kept typing it. So you can see here we have these link. The link means something slightly different in skeleton, but it's similar enough that I've gone with it here. But you can now define a variable that this record goes into, so you can directly reference it. But you don't need to. You can just do that, and it will go through all the different things and do this bit of code multiple times. What it should do is you shouldn't need to do that. You shouldn't need, these things are all, everything you define within a link block is assigned to that record. Or if there's like multiple levels of link cows, right? Then that will be essentially the same as writing cows things in there, but it doesn't quite do that yet because I did everything. I did the complicated stuff, and so I'm like moving on to something else for a little bit as a change. And so I haven't quite done this, but this is relatively trivial. It's very trivial to get this to actually work properly. And that should be thing. And you could sit there and say, well, shouldn't this have a $sign in there? Like, I think you can put it in if you want, but you don't have to. It has to be a $sign there though. And it should be thing. All right. But anyway, this is how the whole point of all of this. And you might be wondering, what is the point of this? Is so I can refer to code that has been generated on an ad hoc at a generations generation time. But and so here I may have a whole bunch, and this is going to play out. So the reason this is going to play out, like where is the here. So in my code block, I'm going to have a whole bunch of, so when I do a code block has a sub block of all these commands, right? I have to go through, and this might involve me creating variables. It might involve me creating classes. So I have to be able to refer to what class did I create for this particular block? What class did I do? How do I refer to them when I go through this exact same list and some other piece of code somewhere else? How am I connecting the two up? So in the skeleton example, it did this because if you did the same pattern, so if I have another link somewhere else, but within the scope of this, then I can just say build states, and it knows what I'm talking about because it managed this sort of pattern of links that going down. Like it's hard to explain, but the whole problem with these things is how do you link up the two types of things. I'm trying to find a good example of like the standard. No. Oh, here we go. Oh, kind of. That's not what I really want. The only difference thing is that skeleton does something that I don't know if I'm going to have to do that this current framework doesn't do, and that is you can create you can do the same link blocks. So the link blocks here are very, very like varied. You can do link blocks around classes. You can do link blocks around statements. You can do link blocks around parameters to functions. So this is the function here, and it's taking this link block, which is defining a whole bunch of stuff. And if I can find an example. Yeah, so here I've got a link block, and so for everything that's of a supplied value.result type, and then you have a string type one that will have a string value parameter, and then down here you're doing the exact same, as long as it's the same pattern. So as long as it goes supplied value dot result type dot string type in your link. So we've linked down to another level. So because we're at this level here, we know what value it is. It's this one that's defined here. This is how it links everything up. So then I can have this function which takes these parameters, and then I'm passing it onto here. The only problem is I can't check if I've got all this correct. So another example is here. This is string type, and then we're going through and we're passing in these values, and then we're assigning it to the value. There's a you can actually just write double, and as long as it's the same stuff, there's shorthand for all of this. Then you're assigning different. It knows what value you're talking about, and of course you could have given this a better name like value. I don't know, whatever you want to call it. By the way, I always put underscores after instance variables. That's not part of the language. It's just my personal thing. And of course, so this language doesn't allow you to do that at the moment. You can't do at links within. You can just do links for code, classes, and instance variables and functions. But you can't do that for this, and you can't do that for implements. So you could also implement. It's not obvious in the skeleton stuff, but this also happens when you do implementing. So you might implement, and that will also have a link. So I could say at link blah blah blah, and then I could choose to implement. And the thing is, I don't think this should be a problem because this is designed to write code for user output code. It's like it's so in this case, I'm making a final product. I'm outputting code to do something for an everyday general user. I'm not outputting code for a programmer. So I think I'm not going to need to add that in because it becomes slightly complicated when I then try and check that I've got all the correct parameters and they're in the right order. And so I want to keep much stricter type checking and compile time checking than Glitter does. Glitter doesn't check that the functions have got the correct values because it just becomes a little bit too difficult to do that. I think I can pull it off, but like obviously, I mean I might not be able to catch it at compile time, but I could catch incorrect parameter, incorrect message signature, not message, function usage at generation time. So this thing to always remember that this is an extra step. So hopefully, I don't think I've explained this very well, but I've been working on this to get this little thing work, to actually understand what I was trying to do and how I got to set things up. This was actually took me more time than everything else. So this here is saying I have a class called testing, which is defined somewhere. But for every different thing in things, I create a I create an instance variable, and I create a function called doThing. I will actually try and run this so you can see what it generates. Hold on. It's going to tell me that I have to, yeah, hopefully I haven't damaged anything. Hold on a second. Oh, put it in the wrong window. So here's the console output. Oh, it's just disappeared. So the console output, so what did this translate into? Well, we've got our test thing class here, and so there are 3 different things supplied to it, and they are called 1, 2, and 3. And so we've got the code. So the first thing is being defined as thing 1. So that was thing.name was 1 in this case here. So we've got, and it's converted into a string. So it's smart enough to know that what you want here is a string, and it's smart enough to know here that you're part of an identifier. And then it's created doThing1, doThing2, doThing3, and a random non-doThing, which is down here. So this is doThingX. So they do have to have separate names. So again, there's some scoping issues. You have to understand the scoping is different for the target language as to the generating language, mostly. Sometimes it's the same. And then down here, it's just translated this code into let t equals new thing, then the doThing. So that's calling the doThing method. And then we're going through the loop, and we're calling, so whatever was attached to this record, and we're calling it on this. So it knows, like, it matters. You can't just do this with any random variable. It's not saying find me the doThing function that's just, it's find me the doThing function that's attached to this object. So it becomes weird because in the generator code, the target variables are actually variables in a sense that are used by the generating code, but so are the types. So types are variables for generating code. So there's a lot going on under the hood that took a while to work out exactly how it's supposed to work in a nice typed way that will allow me to check errors. But this should hopefully make the final code generation stuff much easier to understand and to check that I've got everything correct, and much less tedious than actually having to work with horrible. Where did that come from? That must be an idea I had. Oh, it is. It's the expression idea. I must have decided that I don't need that. Anyway, I may add that at some point. Yeah, the frame. So the point is, now I've been working for the framework. I'm pretty sure it's all rock solid right now. I can add lots of cool things in, and it's going to make it much easier to write the HTML output for Glitter, and everything is kind of well set up to add different languages. So if I want to output C or Dart, or in fact Java itself, that should be pretty straightforward. Much easier. That will take like 2 weeks for a language, I would say, to get everything going. And the nice thing about this is that this again is not, unlike Skeleton where it was generating vast amounts of code to output all of this, it's only generating the design interaction code. So the rest of this can be edited by the user within Glitter at some point, hopefully. So you can add extra functions, or you can change the way that it outputs the code and then save those off and have new libraries. And people can add code and change things that way if they want. So it's another sort of extra way of allowing people to add functionality. So hopefully this will go well. Now, the one thing I was going to talk about, I did start talking about Glitter. So we started off with Glitter and talking about the weird way it handles local variables, as to why does this work but this doesn't work. So I just move that out of the way. And the reason is that Glitter is also the same kind of language, because these languages that I've just been talking about are not my only efforts at creating code generation languages. In fact, I've made a couple other ones, and one of them is Glitter itself. So Glitter is trying to be smart. It's trying to incorporate everything together. And so what happens here is that a variable is not necessarily, if you declare a variable, it doesn't necessarily mean that it's going to be outputted. If I was to compile this and if I was to export to a Scratch project, there will be no X variable and there will be no Y variable in the project. Even if I was like, if I did change that to say, because print doesn't get outputted to Scratch projects, but say would. And so you have, you might be wondering, but how can I do that if these variables don't mean what you think at first? Like, I'm trying to get my train of thought here. The thing is that in Scratch, when you compile it, it's requires, what did I forget to change? Oh, why did it do that? Oh, right, okay. Because I changed it to print say. So that's the funny thing. All right. So we have to explain what's going on here. When I compile it, it will say it right here. About to generate blueprint. For some reason it says it twice. Maybe it's doing it twice. And then it says blueprint built. And weirdly enough, why does it actually say it after it said that? Who knows? I think it must be the way that I must store up the output. I had to think about that. The reason is that this code is not being printed by, if I run the flag, it does do it. How does this code even work? Oh no, I know how it works, of course, right. It is. But why does say not work? That's interesting. Say should work. So I've made a mistake somewhere in my code. Interesting. Okay, we're going to have to explain this because I'm running out of time here. So the important thing is this is how Scratch actually, or Glitter actually works. A variable is a macro variable until it's decided that it's not a macro variable. And so some things are done in the generating phase. And when you compile it, it tries to work out what are macro things and what are target things, what are generating functions and what are target things. So here, I'm feeling a bit nervous. That must do that. All right. Here, when I say x equals 4, because I don't change x, or I don't change x in a context that's output app dependent. So I'm going to call these things app space. App space is like the actual game. So this is app space here. This is it running and doing stuff. Because I don't change x inside something that's an app space thing. So I could go x equals x plus 2. And that will still... what did I do? That works, but it starts off... What has it done? Have I made a mistake somewhere? Oh, we're looking at the wrong code. What are we in? We're in the apple. All right. So in the apple, you see that x is 6 down here because I've changed it up here. And that doesn't make any sense if you're writing Scratch code. It's like, where does this code get executed? There's no block for it. But I can do that. I can go print moo .x. And that should probably run. It does. It says moo. But you may notice that it says moo before it says blueprint built. So we'll come back to what a blueprint is. This is the print statement in the generating phase. So this is a macro print statement, and this is a macro change to x. And so what happens is, because I don't change x here, it's not actually creating a variable in app space. It's not creating a Scratch variable. It's just substituting x where you have x here. It's substituting it with what the current value of x is when it goes through the generation phase. So it's treating this as outputting this as code. Well, it's outputting what I call a blueprint, which is the final code that's actually run by the outputs. And you can do local variables, because as long as you don't actually do you're not doing something that's so there are two rules. So the important thing is variables are promoted to be app space several ways. One of them is I go app at the front of it. That forces X to be an app variable. The second thing, so another way is doing that is using it in a app dependent context. So if I go turn left Y, the reason this fails is this is a app dependent command, right? This has to happen when you're actually doing the app, right? Turning left doesn't make any sense. So suddenly this repeat goes from being a piece of code in the generating phase to a piece of code, a repeat loop in the output in the app phase. And this no longer makes any sense, because it can't, this in order for this to happen, you have to promote. So if you're going to turn left, this variable now has to be promoted to be an app variable for it to make sense, right? Where at least, like, it's very hard to explain the variety of rules here. And so I think if you go like that, it should be, it should be fine. So you're like, again, it's confusing. How is it doing this? But the problem is when I do this command, this becomes an app-dependent loop. And if it's an app-dependent loop, and then I try and change a variable in an app-dependent loop, then it has to become an app variable, right? And so this is trying to turn this generator variable by default into an app variable. And it can't do that because it doesn't support local variables. So now it's complaining, oh, you can't do that. You can't go changing things. So I can refer to macro generator variables, but that's just going to put the value, it's just going to output turn left 5. And because you've got it, well, hold on. If you want to, if you didn't have this command, this repeat would be a macro space command or generator space. So it would basically do a loop when you're doing this. So before it's got to here, it has done that loop. So it's done that loop as part of the generator. And when I click on this, it's doing that loop over and over again. So you could sit there and you could go like that, and then you can go like that, and it's pretty fast. All right, hold on. And you can see there's a slight pause there. We'll add one more for good luck. So now it's generating the code, and then it's finally finished, and it's printed out that number. All right. So it did this thing within the generating loop. Now you can be clever, and you can turn the repeat, you can force it to be a generating repeat. So I could, with a star. So there's some, or maybe it doesn't work. Maybe it doesn't work for that. It does work for other things. So while is less than 20. So why does repeat star not work? It doesn't seem to like me doing that. But it should work. I don't know. I must have. It's a very complicated thing. But anyway, the problem is, and the point is that you can do some weird things. You can repeat. I think you can do this. I think you can go repeat 2. We're just going to do it like down here. We can repeat 2. Does this work still? I don't know. I haven't done this for ages. It does. Why does it only do it once, though? I would have thought it would have run it twice. Well, anyway, I don't know. But anyway, the final point of all of this is I feel like I can. Okay. Maybe repeat loops don't work. While x is less than 8. Can I do this bit of code? I want to find out x equals x plus 1. Because why is it not actually creating multiple flag blocks? It's still not going to do it. That is weird. That should... Maybe I'm going to look. I've never actually tried doing that, but it should actually create multiple flag blocks, and those flag blocks should all say this thing. So it should be running it multiple times, and it should be printing out x. You should see a bunch of different things because it's running it multiple times, but it's not. Who knows? Anyway, I thought that would be interesting to go through in a very rambly way how things work and why things work in Scratch and what's really going on. And yes, I haven't quite obviously got this perfect. There's a whole bunch of different rules for like working out whether or not you need to promote a variable to be Scratch, to be app space over macro space. And that is actually one of the bugs recently. The last thing I'll say is that up until recently, sometimes when you use plus equals, it will do a weird thing. So we have to get rid of this code. It won't do it anymore because I fixed it. But, alright, we'll just have to edit the video. Alright. Oh, that's very loud. So anyway, hold on. So don't worry about that again. I was going to say, so up until recently, if you'd done this, it would have complained that you couldn't use X in it would have complained about doing that because it didn't properly promote variables to app space using these adjustment operators, so plus equals and minus equals and that kind of stuff. But that has been fixed. So the next version, that will work fine. But the reason that it didn't work is because it wasn't promoting it to an app variable when it should have been. So I hope that made some sense. So, all right. Thanks for watching and have a good time in life. Bye. And yeah, so I'll just finish up and say, next version, some language bugs fixed. That one in particular, there's a constructor bug with the internal runner. There's a few layout problems, and there's another problem with the undo redo in the image editor. They will all be fixed. And there will be a cool sprite sheet tool, which I'm not going to show you what I've got so far, but it's coming along. So that you can import sprite sheets and then export those. You can add those to costumes in objects or create sprites out of sprite sheets, which could be a useful tool. And I kind of want to add every new release to have some sort of interesting little extra tool added on. So yeah, thanks for watching. And oh yeah, if you've watched this far, please consider donating money or somehow signing up to Patreon or something, because I really want to keep working on this, but I have very limited means to do so. So it would be handy if you could help out even a little bit. I don't need that much money, but I do need a little bit of money because I just can't do it anymore. Anyway, thanks. Bye.